Okay, so I'm going to continue off here. This is part 2. We were talking about trapping, and I just want to, make clear that you don't need to trap objects yourself. So InDesign will do a lot of trapping for you. Illustrator will trap for you, and it's something that the pre-press department does at the print shop for you. They do that for your artwork to meet the specifications of their presses. So it's nothing that you need to do specifically to your artwork, but it is something you need to be aware of, and especially when you're looking at printed material, you want to look for misregistration. You want to look for if your printing is off, like that, or trapping issues where you might have white gaps and things in your printed work. That way you can do a quality check on your own stuff. And then if the print shop says, hey, we're having trapping problems, you'll know what they mean when they start talking about that, and you might be able to fix some of that. So a way to fix trapping, or when trapping's not really an issue, is like in this image here, when you have a similar combination of colors that are in the adjacent objects. So the A is built from cyan and magenta, and the background is built from cyan and magenta. So there is a continuous flow of color between the objects there, between the letter and the background. So there won't be any white gap, and a colored gap like this is really, really difficult to discern with your eye, especially on small pieces. So trapping's not really a big issue there. Yeah, so it's just something to look for. If you can find a trapping error or a misregistration on some printing, I'd like you to bring it in. It'd be kind of neat to share. I have a few examples I'll share at another time. Okay. So how does this continuous tone of this eyeball here, how do we reproduce that with print production? So it's a very specific science and a specific way of reproducing tonal value in print production. And when I say tonal value, I'm talking about going from black to white with all the grays in between there. When you'd get a photograph, in the old days with film, a photograph, it would be this smooth gray going from a dark to a light. But to reproduce that, they would have difficulty reproducing that. And so they came up with the halftone dot. So the halftone dot is converting these grays to these dot patterns. This image below here shows, okay, there's gray, and as you zoom in, you can see that it's these dots arranged in a grid. And in this image of the eye, you can see that it's the dots, all the grays are changed to these dots arranged in a grid. That allows the printing plate to have the dots on them, pick up the ink and lay them down, and be able to reproduce thousands of copies that are the same. So when we're looking at CMYK printing, the halftone dot is the key to the whole thing. It's what everything is made of. I have a loop magnifying glass in class, and you should come and look through it and look at some printed material, and you'll see how your eye is fooled. So this is very tiny dots, and when we look at it, our eye blends it all together, and it looks like a continuous tone. But in reality, it's these tiny dots of the CMYK colors. So here, they call it a screen. When it's the dot in a grid, is called a screen, and the screens are laid at different angles to each other to create certain patterns here. This is a rosette pattern, which is good. Our eyes don't really discern a problem with that. When the screen angles are off, they'll create these moire patterns. And in this module, you're going to go and research Moire on your own, find some examples. This image here just shows how various colors are made through the various combinations of dots. And so you can see the bigger, thicker the dot, the more ink is down, and so the darker, the denser the color. So here, this magenta on the bottom row is a much darker use of magenta than in the middle row. So we'd say this could be like a 50% magenta, where this magenta here is probably only 5% or 2%. And this might be a 10%. So the different percentages of ink combine together to create certain colors. Here is just showing a photograph. You zoom in and you can see the dots and the rosette patterns that create the illusion of a continuous tone photograph. So if you notice, the dots in the halftone screen are in a grid, and they just get bigger or smaller. They're always evenly spaced apart, and they just get bigger or smaller dots to be a denser or darker or lighter color. This is dot gain. So this is the tendency for ink to spread out when it hits the paper. So that dot gets laid down, the paper will absorb a little bit of it, and it'll expand the dot, and that's called the dot gain. The dot gets bigger, which makes the color darker. So different papers have different dot gains, and it all depends how the paper is coated. So like a newsprint, which is very fibrous and uncoated, absorbs ink, and it has a big dot gain, like 20%. That's a big dot gain. Where coated papers will not spread as much, and they might only have a 5% dot gain. Sometimes you have to be aware of that. If you're sending artwork to a newspaper printing, then you need to take into account the dot gain when you are doing the color correction on your photos. So if your photo looks kind of dark and you're sending it to a newspaper, it's going to come out much darker. A lot of times in file preparation with newspaper photographs, the images look too light. But once they're printed, they come out the correct darkness because they've put in for dot gain. They accommodated for the dot gain. Okay, that's going to end our slideshow here, and I suggest you review this multiple times. All right, thank you.